we have to be careful sometimes when we're finding inverses. Let's do one last example. F of x equals the square root of the quantity x minus 2. To find its inverse, let's switch x and y. Let's see, to undo the square root of something, I know I have to square both sides. X squared equals y minus 2. And now I have to add 2 to get y by itself. So according to this, if f of x equals the square root of x minus 2, then f inverse of x equals x squared plus 2. Algebraically, no problems, but let's be careful. I want to sketch a graph. I'm just going to make a quick sketch of what each of these looks like. Square root function, I know the shape of that, and I know it's shifted 2 units to the right. So f of x is going to look something like this. All right. If I look at my equation for the inverse, it says x squared plus 2. I know what that looks like. That's a parabola, x squared, shifted up 2 units. That would look like this. But there's something very, very not okay with these two pictures. I know that a function and its inverse should look like reflections over the line y equals x. But if you imagine reflecting just that one arm of f of x, we don't get a whole parabola. In fact, we should only really get half a parabola. So what happened? Notice in our algebra, I squared both sides and turned our square root into really an x squared. That created kind of this extraneous arm that we weren't interested in. So how do we fix that? Well, graphically, we of course would only care about that right-hand arm of the parabola. Algebraically, I have to add a restriction on the domain. I only want x squared plus 2 only from 0 on, so only on 0 to infinity. This is our inverse. Without that added restriction on the domain, it's not correct. It's not a correct inverse. I have to tell the person reading this that I only want the right arm of the parabola. I only want half the parabola. How did I know that? Well, because I know I started with a square root function that only looked like half a parabola, only looked like one arm. Another way of thinking about this is investigating the domain and range. I know the domain of f of x when we started was 2 to infinity. And the range was 0 to infinity. Remember, one of the properties of relations and their inverses is that the domain and range switch. So the domain of our resulting inverse has to be 0 to infinity. The resulting range has to be 2 to infinity. But if I graphed the whole parabola, my domain would not be 0 to infinity. It would look like the domain is negative infinity to infinity. So the trap is, if you're starting with a function with a restricted range, then your inverse will have a restricted domain, and vice versa. And if we don't say that, if we don't say our restrictions on the domain when we write down the equation for the inverse, then it's not correct because you're telling the person to graph more than we need. So we just have to be careful. So what I recommend is that you go through and you try to pick out the main key facts here, and I've highlighted a bunch of them in this video. Domain and range switch in inverses, x and y coordinates switch in inverses, the graphs are reflections of each other over the line y equals x, how to find the inverse algebraically, the fact that they undo each other. So there's a lot of properties here that are important. Good luck!